Hello again. The SAC64 language supports now byte array assignments. Let's have a look. Let's start by looking at how a classic Hello World program is implemented by using an array assignment. The program defines first letters as constants. It then defines two arrays. The first array contains the text Hello World. The second array points to the screen. In the program body, the Hello World array is simply assigned to the screen array. As a consequence, the text is displayed to the screen. Let's run the program. Of course, the array assignment can also be used for copying text on the screen. Let's modify the program so that it copies one row of the screen to another row. Let's run the program now. Moreover, there is no reason why the arrays cannot overlap. Let's modify the program so that it copies one row of the screen on itself, but so that there is one character offset. In effect, this causes the text to scroll to left on that row. We can now run the program to see it in action. Let's run the program again. As the array assignment copies elements starting from the first index, scrolling the text to right fails if we just reverse the assignment. We can see that by running the program. The entire row disappears. The reason for the failure is that when the array assignment copies the first character to right, it actually determines the value of the next character to be copied. In effect, the array assignment fills the entire row with the first character of the row. We can change the character and run the program to see that this is the case. But what if we really would like to scroll the text from left to right? Could we do that by using the array assignment? Well, yes, but we would then have to use a modifier to make it work. As mentioned earlier, the array assignment copies by default the elements starting from the first index. But in our case, the copying of elements should start from the last index and progress down towards the first index. For this purpose, there is a down modifier. Let's add the modifier to the program and see how it runs. The SAC64 compiler comes bundled with an array assignment example that scrolls text on the screen continuously. The program first defines constants and variables for the scrolling. The program body consists of an infinite loop. Within the loop, there is first a busy loop that waits till the scanline is on the lower part of the screen to avoid any artifacts. Then the program uses a counter variable to skip some screen updates so that the scrolling has the speed about 20 characters per second. The rest of the if statement does the scrolling. It first copies characters that are about to scroll out of the screen to a carry array. It then scrolls all the characters from right to left. Lastly, it copies the characters from the carry array back to the right side of the screen. The last busy loop waits till the scanline is on the top of the screen so that the main loop can start again. Let's run the program to see how it works. So the program slows down the scrolling on purpose to keep it readable. We can comment out the delay to see how the program scrolls the text with each screen update. Now that is much faster, but it's harder to read. So, how fast can the program actually scroll the text? We can comment out all the busy loops that slow down the scrolling. Well, it moves. The screen capturing has definitely hard time to follow the changes. As for the bytecode optimization, let's consider the array assignment in the bundled example. It gets translated into a single instruction in the intermediate representation language. The instruction has a simple translation to bytecode. This is possible because the microprocessor of the Commodore 64 supports indexing of byte values in memory. So that is what the byte array assignments look like. Next, I'll be working with the integrated development environment. It needs to be improved before new features can be added to the language. Anyhow, thanks for stopping by and see you soon.